This is Geometry, section 2.6, Proving Angles Congruent. So, a theorem, you've probably heard that word before. A theorem is a conditional statement, so an if-then statement that has been proved to be true. So we'll use theorems in the reasons column of our proofs. Some important theorems that we're going to deal with. We've kind of talked about both of these already. So if I have vertical angles, then those angles are congruent. Remember, that's the most important thing to remember about vertical angles. Vertical angles are congruent. If perpendicular lines, then there are congruent right angles. Okay, so perpendicular lines form right angles, so obviously those angles are congruent to each other because they're all right angles. Next we've got this right here. So if angle 1 is supplementary to angle 2, just like it is in this diagram over here, and angle 2 is supplementary to angle 3, like it is in this diagram over here, then we might be tempted to say that angle 1 is supplementary to angle 3, because that's kind of like the transitive property. 1 is supplementary to 2, 2 is supplementary to 3, so 1 is supplementary to 3. But if we look at this diagram, if we look at angle 1 and angle 3, those are actually vertical angles. Those are congruent to each other, not supplementary to each other. So if 1 and 3 are both supplementary to 2, then angle 1 is actually congruent to angle 3. So this conditional statement is called the congruent supplements theorem. So to write that out more formally, a congruent supplements theorem, or the congruent supplements theorem, says if two angles supplement the same angle, then those two angles are congruent. So if two angles are supplementary to the same angle, just like we had 1 was supplementary to 2 up above and 3 was supplementary to 2, then those two angles, 1 and 3, are congruent to each other. Congruent complements theorem says the exact same thing as this, but with complementary angles. So if two angles are complementary to the same angle, then those two angles are congruent to each other. Another theorem we have is if two angles make a linear pair, so if I have a linear pair, then I have supplementary angles. We know that a linear pair makes a straight line. Straight line adds up to 180. That's the definition of supplementary. So if I have a linear pair, then I have supplementary angles. If I have two right angles, so if both angles that I have are right angles, then obviously those angles are congruent to each other. So these seem kind of obvious, but we're going to use these when we're trying to prove things. So, for example, if I've got, given that angle 5 is a right angle, so this right here is a right angle, given that PT is perpendicular to GE. So this would be perpendicular, which means this would also be a right angle. We're trying to prove that angle PEG is congruent to angle 5. So our given is angle 5 is a right angle, and PT is perpendicular to GE. So that's given. Next thing that we notice, well, if this is perpendicular, then angle PEG, which we're trying to prove is congruent to angle 5, so angle PEG would be a right angle. Angle PEG is a right angle because I have perpendicular lines. So, since I have angle 5 is a right angle PEG is a right angle. Up here, we said if I have two right angles, then those angles are congruent to each other. So, angle PEG is congruent to angle 5 because they're both right angles. Another proof, so I'm given that angle 2 is congruent to angle 3, so I'm going to mark those congruent. So angle 2 congruent to angle 3, given. I'm trying to prove angle 1 is congruent to angle 8. So the only other thing I can write down on here right away is that I noticed that 1 and 2 are a linear pair, and 3 and 8 are also a linear pair. So angle 1 would be supplementary to angle 2, and angle 8 would be supplementary to angle 3. The reason is that those are both linear pairs, so linear pair means that they are supplementary. Remember, this arrow means if then, so if linear pair, then supplementary angles. So 1 is supplementary to 2, 8 is supplementary to 3. Then, since we were given that 2 is congruent to 3, I can now substitute 2 and 3 for each other. So instead of saying 1 is supplementary to 2, I could say angle 1 is supplementary to angle 3. And that would just be substitution. I'm substituting angle 3 for angle 2, since in the first step I said that those two things were congruent. Now that I've said angle 1 is supplementary to angle 3, and angle 8 is supplementary to angle 3, I can say that those two things are congruent to each other, because that's the congruent supplements theorem that we talked about earlier. So angle 1 congruent to angle 8, congruent supplements theorem. Last proof, so we are given that angle 1 is congruent to angle 2, so angle 1 congruent to angle 2, that's given to us, so we can mark that on the diagram. We're trying to prove angle 3 is congruent to angle 4. So, it's also given to us that angle 5 is a right angle, so that's not really stated, but we can notice that angle 5 right here is a right angle. Next step says if I've got angle 1, angle 3, and angle 5, if I add those all together, 1, 3, and 5, that equals 180. The reason is because those all make a straight line. We know that a straight line equals 180 degrees, so if I add these all together, that makes a straight line, that's 180 degrees. Now I've got measure of angle 1 plus measure of angle 3 plus 90 equals 180, so I changed the measure of angle 5 to a 90. We said, well, this little square right here tells us that angle 5 is a right angle, so I'm just substituting that value in. The measure of angle 5, I know that that's equal to 90, so I'm just substituting that. Substitution. Then I've got measure of angle 1 plus measure of angle 3 equals 90. So I took this 90 right here, and I subtracted it from both sides. It's just subtraction. Next, I've got measure of angle 4 plus measure of angle 2 equals measure of angle 5. Well, if I look at 4 and 2 together, 4 and 2 added together would be this angle right here. That's a right angle also because that's actually vertical from angle 5. So this right here, this angle, 4 and 2 put together, is vertical from angle 5. So the reason I can say 4 plus 2 is equal to 5 is because those are vertical angles. Now I've got 4 plus 2 equals 90. Well, again, like we did up here, substitute 90 for the measure of angle 5. Substitution. Now I've got measure of angle 4 plus measure of angle 1 equals 90. So I changed 2 to 1. I can do that because up here we said angle 1 was congruent to angle 2. So that's more substitution. Then finally I've got measure of angle 4 is equal to measure of angle 3. So that kind of seems like it came out of nowhere. But if we look at this, we've got measure of angle 4 plus measure of angle 1 equals 90, which means these are complementary. They add up to 90, so these are complementary. Then up here, I had that the measure of angle 1 plus the measure of angle 3 was equal to 90. So those are complementary. Since I've got 4 and 3 both complementary to angle 1, I could say 4 and 3 are equal to each other or congruent to each other because of the congruent complements theorem. Two angles complementary to the same angle means those two angles, 3 and 4, in this example, are congruent to each other.